Today we're going to talk about something called the mean value theorem for integrals. We had a mean value theorem before, and what that said is if we have a function, okay, a continuous function, that was important. Sorry about that continuous function. That was kind of terrible. Okay, and if we have these points, okay, we'll call this A and B. If we look at the secant line through A and B, the mean value theorem said that somewhere in this interval there's this point C where the tangent line is parallel to that. Those lines are terrible, but you get the idea. Okay, so that was the mean value theorem for functions, is that between these 2 points A and B, there was some point C where the tangent line was parallel to that secant. Now, the mean value theorem for integrals says if you have a continuous function, then there's a number C, and you can kind of see these things here. Here's A and B. So we've got this continuous function, and that's telling us that there's this point C here somewhere, that the y value of C is the average value. So remember that Desmos activity that we were doing where we're trying to find the average value? This is saying that there is a point where there's a point C, that's an x value, where the y value associated with it is the average value of the function. The way we write that is this formula here. It's the integral from a to b of f of x, so that's the entire area under the curve, is equal to the y value at c times b minus a. That's the mean value theorem for integrals. So let me show you how this works. We want to find the value of c guaranteed by the mean value theorem for this function, cosine x, on the interval negative pi over 3 to pi over 3. So we are looking for integral from a to b, so that's from negative pi over 3 to pi over 3 of our function f of x, which is cosine x. And somewhere there is f of c, so there's some value cosine of c times b minus a is the pi over 3 minus negative pi over 3. Okay, so this is what we're looking to solve. So we need to work both sides of the equation here. So starting with the left, the antiderivative of cosine is sine. So we're looking for sine. We're going to evaluate from pi over 3 to negative pi over 3. And over here, it's going to be plus, so we have 2 pi over 3 cosine c. All right, so to evaluate this from pi over 3 to negative pi over 3, we have the sine of pi over 3 minus the sine of negative pi over 3. And let's see, sine of pi over 3. We can draw, oh my goodness, straight lines are really hard. I don't know what to tell you. Pi over 3, that is a 60-degree angle. So we have 1, 2, root 3. So the sine of that is going to be root 3 over 2. Negative pi over 3 is going to be the same value, except we're in this quadrant where all students take classes. So just in this quadrant, it's going to be negative square root of 3 over 2. Oh my goodness, my handwriting is terrible on this thing. Okay, so if we add that, root 3 over 2 plus root 3 over 2 is just going to be 2 root 3 over 2, otherwise known as root 3. And then I'm going to multiply by the reciprocal here. So that gives us 3 root 3 over 2 pi equals cosine c. And this is obviously not something that we can do using special triangles or anything. So you're just going to have to do that in your calculator. You're going to have to take inverse cosine of 3 root 3 over 2 pi. That's going to give us our value of c, which c turns out to be, I don't know, I don't have a calculator right here. 0.597 is what the calculator says. But I think we need the negative one as well. Yeah, because the calculator is only going to give us the positive one. And there's going to be a negative one as well. So negative 0.597, the negative value, because we can be in both quadrants there. Okay, so that is what the mean value theorem for integrals look like. In the next video, we will talk about average value, which is what we did our Desmos activity on last week.